morning, students. I'm Krishna Rao, Assistant Professor in CSC Department. I'm handling compiler design for 5th semester. We'll discuss predictive parsing method in compiler design in today's class. In today's class, we'll discuss predictive parsing method. Here, predictive parser is a recursive descent parser which has a cable to predict which production is to be used to replace the input stream. Here, the predictive parser does not suffer from backtracking. Here, in this predictive parser, it is a non-recursive descent parser. Normally, recursive descent parser will consist the recursive functions in the program. But here, there will not be any recursive functions. Here, we construct the tables. We build the tables. From the table, we can predict which production we can use to replace the input stream. Right? So, building the tables can be automated. So, we can construct the predictive parsing table automatically. Right? It is a non-recursive top-down parsing method. Predictive parser is a non-recursive top-down parsing method. So, it removes the backtracking by fixing one production for every non-terminal and input token. Right? So, in the table will consist the rows and columns with the non-terminals and terminals. In that table, we specify which production that we have to use for the combination of the non-terminal and terminals. Right? So here, predictive parser can be implemented by maintaining an external stack. Accepts only LLK grammars, hence it is called LL1 grammar. So an updated or modified predictive parser method we refer as LL1 parsing method. So LL1 parsing method is one of predictive parsing method. So this is a model of the non-recursive predictive parser. Here, this is a parsing table. For each and every grammar, we construct a parsing table. It consists of rows and columns with terminals and non-terminals. The rows are represented with the non-terminals and columns are represented with the terminals. Right? Rows are represented with the non-terminals, columns are represented with the terminals, and we use the predictive parsing program. Right? This predictive parsing program will uses a stack. It uses a stack, and it will store the non-terminals in the stack. It will refer the input terminal symbol. It will refer the input terminal symbols on the tape, and it will refer the top of the stack non-terminal, and using them it will refer the parsing table. In the parsing table, it will have a production for the combination of the non-terminal and terminal. By using that, it will perform the operation. And finally, it gives the output. Is it accepted or not? Right? So, the parser has an input buffer, a stack, parsing table, and output stream. Right? The predictive parser has an input buffer, a stack, a parsing table, and an output string. The input buffer contains the strings to be passed followed by $sign. The input buffer will contains the strings to be passed and end with the end mark $sign. A symbol used to indicate the end of the input string. The $sign is used to indicate the end of the input string. Then the stack contains a sequence of grammar symbol with $sign on the bottom. Indicate the bottom of the stack. Initially, stack contains the start symbol S of the grammar on the top of $sign. Stack is to hold the left sentential form. Right? The stack will contain the grammar symbols with the $sign. The $sign indicate the bottom of the stack. So initially it will have the starting variable S. Right? Then the output string shows the derivation steps for the grammar to produce the input string. Right? The derivation steps for the grammar of the grammar to produce the input string. Predictive parsing uses a stack and a parsing table as a data structure to parse the input and generate the parse string. Right? Parse table is a two-dimensional array, right? M of x comma a, where x is a non-terminal and a is a terminal of the grammar. Right? The rows are non-terminals, columns are terminals, entries are the productions. So for every combination of the non-terminals and terminals, we write a production which is to be considered. The both stack and input contains an end symbol $sign to denote the stack is empty and the input is consumed. Right? $sign as an end mark in the stack and also for the input buffer. The parser refers to the parsing table to take any decision on the input and the stack element combination. So our parsing program, our parsing method takes the input symbol from the input tape and one symbol from the stack, and it refers the parsing table. By referring the combination, it will decide which action it has to take. So to apply the predictive parser, we must remove all the unreachable productions. We must remove the ambiguity in the grammar. We must eliminate the left recursion, and left factoring of the grammar is considered, and we have to find first and follow of the variables, and we construct the parsing table. So using this parsing table, we will perform the predictive parsing method. Right? So using the first and follow, we construct the parsing table. Using the parsing table, we will perform the predictive parse. Right? Here, a grammar is given and output is parsing table M. Now we will specify how to construct the predictive parsing table. For each production, A gives alpha to the steps 2 and 3. For each production, A gives alpha to the steps 2 and 3. Now, what is the second step? It says for each terminal A in the first of alpha, add A gives alpha to table A row and A column. It is a row, this is column. Here we write the production A gives alpha. We write the production A gives alpha. But where we have to write? So we consider first of A, that is first of alpha. The first of alpha has terminal A. For each terminal A, we write M A comma A. In that table, we write this production A gives alpha. Simply, we consider the first of variable A, that is first of alpha, which has terminal A. So for all the terminals A, we write the production A gives alpha in the row capital A, column small a. In the table predictive parsing table. Now, if epsilon in the first of alpha, if epsilon is in the first of alpha, we must consider follow of A. If follow of A as the terminal B, we must write this production always in the A comma B combination. If epsilon is in the first of alpha, then we considered follow of A. If epsilon in the first of alpha, then we must consider follow of A. If the follow of A has a terminal B, if the follow of A has a terminal B, then for this combination M of A comma B, we write the production A gives epsilon. We write A gives epsilon in all the columns of B in row A. This is a row, this is a column. If epsilon is in the first of alpha, dollar sign is in the follow of A, we add to A gives epsilon to A comma dollar. Right? If epsilon is in the first of alpha, dollar in the follow of A, we add A gives epsilon to A row and dollar column. Right? Make each undefined entry of M to be M. So first we consider the first of variable. If first of variable is epsilon, then we consider the follow of the variable. If the follow of the variable is dollar sign, contains dollar sign, so we write the production A gives epsilon to the A comma dollar. Okay. Now, already in the last class, we have discussed the productions and its non-terminals and first of the non-terminals and follow of the non-terminals. So in the last class, we have determined the first of the variables and follow of the variables. Now, our step is use them first of the variables and follow of the variables and construct predictive parsing table. Then use the predictive parsing table and perform the predictive parsing method. Right? Using the predictive parsing table will perform the predictive parsing method. Now, here, what is the first production? Production 1, 2, 3, 4, 5, 6, 7, 8. 8 productions are there. We representing all the rows with the non-terminals, all the columns with the terminals. All the rows with the non-terminals, all the columns with the terminals. Now, first production, the first variable E. where we have to write this first production. What is the first of E? Left parenthesis and ID. Right? Left parenthesis and ID. So, in the E row and in the column ID, we write the first production. In the column left parenthesis, we write the first production. We are considering our first production. E gives T dash. Where we have to write this production. The first of E has two terminals. What are the terminals? Left parenthesis and ID. So, in the non-terminal E row, we write this both ID and left parenthesis. We write ID and left parenthesis. Right? So here, in this ID column and in the left parenthesis column, we have written the first production. Right? Now, for the second production. For the second production, for the non-terminal E dash, plus C is the answer. Plus is the terminal. So, in the second row, plus sign, we write the second production. Right? For the second production, the first of A dash is plus sign. So, for the plus sign, we write A dash equal to plus T dash. Right? First of production, second production is plus sign. For the plus sign, we use this one. Now, what is the third production? For the third production, it is epsilon. For the third production is epsilon. If it is a epsilon, then we have to consider it follow of the variable. What is the follow of the variable? Left parenthesis and ID. Right parenthesis and dollar sign. So, for the right parenthesis and dollar sign, we are writing the third production. Where we have to write the third production. For the third production, the first of A dash is epsilon. For the third production, first of A dash is epsilon. Since it is epsilon, we have to consider follow of the variable. What is the follow of the variable? It is right parenthesis and dollar sign. So, in the place of right parenthesis and dollar sign, we write the third production. For the plus sign, we write the second production. Right? For the plus sign, we write the second production. For the right parenthesis and dollar sign, we write the third production. Since first of A dash for the third production is epsilon, we are considering the follow of the non-terminal. Since follow of the non-terminal is right parenthesis and dollar sign, so we are considering here the third production. Right? Okay? Now, for the fourth production. T is equal to FT dash. So what is the first of this variable? Left parenthesis id. So in the place of id and in the place of left parenthesis, we are writing the fourth production. Where we have to write the fourth production? For that, we find the first of that variable t. The first of variable t is giving left parenthesis and id. So in the columns, left parenthesis and id, we write the production. In the columns left parenthesis and id, simply we write productions. What are the production? Fourth production. So fourth production we are writing in the id column and left parenthesis column, right? Then for the fifth production, for t dash, it is multiplication. For the fifth production, t dash and epsilon gives fifth production, right? T dash gives multiplication ft dash. This is the fifth production. Where we have to write the fifth production? The fifth production is written in the multiplication column and t dash row and multiplication column. In the multiplication column, t dash is called star ft dash. Now, for the sixth production, where we have to write sixth production? What is the first of sixth production? The first of sixth production is epsilon. Will results to consider follow up the variable. Since the first of sixth production is epsilon. Since the first of sixth production is epsilon, we have to consider follow up the variables. We have to consider follow up the variables. Then what are the follow up the variables? There are three symbols: plus, right parenthesis, $sign. So in all this here we write sixth production. In all the three columns, we writing the sixth production, right? We write sixth production here. T dash gives epsilon in plus sign row column, right parenthesis column, and $sign column. We write the sixth production. Then seventh production. What is the first of seventh production? For the seventh production is a left parenthesis. So here in the left parenthesis we are writing the seventh production. We write seventh production in the column left parenthesis. id is for the eighth production. What is the first of eighth production? The first of eighth production is id. The first of eighth production is id. So in that one id we write eighth production. So f row and id column we write f equal to id, the eighth production. So First, we consider first of the variable. In the terminal columns, we write the production. If first of the production is epsilon, if first of the production is epsilon, then we consider the follow of the variable. If epsilon is the first of the production, then only we have to consider follow of the variable. So, in the follow of the variable, we write the production, right? So, we have written all the 8 productions in the parsing table, and all the remaining are others. All the remaining blank spaces are simply others, right? So, this is the procedure to construct predictive parsing table, right? This is the procedure to construct predictive parsing table, right? So we have seen how to construct the first and follow of the variables. So using the first and follow of the variables, we are constructing the predictive parsing table. Now we use this predictive parsing table and will perform the parsing of the input string. Now we are considering the input string id into id. We are considering the input id into id. Using this one, we'll write the parsing table and stack. So here we write the steps. What is the stack representation? What is the input? What is the next action? Now, the first step, the stack with $sign and E. The root, the starting variable, will be written in the stack, right? So here, in the first step, we considering the our stack symbols, $sign and starting variable. And input, in the input, we are writing the input string. In the input, we are writing the input id into id $sign. Our next action, refer the table for e and id. We have to consider top of the stack, that is e, and id we have to consider, right? In that we have written the production e use t dash, means pop e and push the symbols e dash comma t. Pop e, push the symbols e dash comma t. So here pop e and push the symbols e dash comma t, right? Now t and id. In the table, t and id is giving as t equal to ft dash. In the table, t and id is giving t equal to ft dash, right? Previously equal t equal to t dash, right? Now, so what we have to do? Pop t, push the symbols t dash comma f, right? So we are storing e dash, t dash and f in the stack. Now it is f, it is id, f comma id. F and id FID. F gives ID. Refer the table in the F row and ID column. It is stored in the F is ID. So pop F push ID. Store ID into the stack. Into stack. Then ID and ID matching. So delete both of them. ID and ID matching. After popping F, storing ID into the stack and input are matching. ID and simply delete. Now, this is the stack symbols. This is the input symbols. Now, what it has T dash, we have to consider. We have multiplication. From the table, the T dash and multiplication, it is having this one. So, pop T dash and store T dash F and multiplication into this stack. Right? The order is must. First we have to store T dash, then F, then multiplication. Right? Right into the stack. Right? T dash and multiplication. So in the table, if you refer T dash and multiplication, T dash and multiplication is T dash F T dash. Right? So here we are performing this one. Right? Then here dollar sign, dollar multiplication, simply remove, and here they will be E dash. This E dash also will be there. Right? Then E dash, T dash and F. F and ID we have to consider. F and ID we have to consider. This F and ID will result to pop F store ID. So simply this ID will be deleted. Then here T dash and dollar is we considered. Next E dash and also dollar will giving as simply E dash gives epsilon will be 0. Simply dollar and dollar is accept. So here E dash and T dash both are with dollar giving E dash gives epsilon, T dash gives epsilon. So the symbols are deleted. So finally the stack is empty, input is empty, the string is accepted. The stack is empty, the string is also empty, so the string is accepted. So here try to do for the input of ID plus ID into ID using the parsing table in the stack. Okay, is it clear? We are using the parsing table. In the parsing table, it will be specified which action has to be taken, which production we have to reduce, and using the stack and input and predictive parsing table, the parsing method will determine which action has to taken. Then finally, it will give the steps for the checking the input string is accepted or not. Right? So here I'm closing this one with this predictive parsing method, and we'll discuss another topics in the next class. So using the table, we are from using the first and follow, we are constructing the table. From the table, we are performing the predictive parsing method. Right? By using this predictive parsing method, we are determining the input string. The input string is accepted or not. If it is any others is there according to the syntax rules of the programming language. So I'm closing this class now, and we'll continue the remaining topics in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.